This work examines how coherence is possible when foundations, cores, and absolute nothing are removed from explanation. Preview summary. What if nothing is not the end of explanation, but the point where explanation breaks? We're used to thinking in foundations. Something must come first, something must lie beneath everything else, something must ground what exists. When that ground is pushed far enough, we often call it nothing and stop asking questions. But what if that stopping point is not a solution, only a habit? This essay begins with a deliberately unsettling question. Can there be less than nothing? Not to propose a new kind of void, but to examine what must already be assumed for such a question to even make sense. Along the way, familiar intuitions are tested, that dependence must point downward, that circularity is always a flaw, that infinity implies chaos, and that explanation must terminate in a privileged core. Concepts like dependency, rerouting, self-reference, and stability are taken apart and rebuilt, not to replace one foundation with another, but to see whether foundations are needed at all. Rather than offering metaphysical answers about what ultimately exists, the essay focuses on structure, how systems remain coherent, how explanations fail, and how limits shape reasoning even when they never appear as things. The goal is not to resolve every question, but to clarify which questions survive once hidden assumptions are removed. This is not a book about emptiness, mysticism, or ultimate truths. It is an exploration of what holds when nothing cannot. If you are interested in the edges of explanation, where grounding, order, and self-reference begin to blur, this essay is an invitation to look there carefully. Philosophical positioning note. This work does not propose a new metaphysical system, nor does it attempt to describe what ultimately exists. Its aim is narrower and more disciplined, to examine how coherence, explanation, and dependency function once familiar endpoints are removed. The arguments in this text proceed from a simple restriction. Foundations, cores, and absolute nothing are not treated as explanatory resources. They are not denied outright, but set aside as unnecessary for the questions being asked. The focus is instead on whether structures can remain coherent through constraint, closure, and stability alone. Readers should not expect answers to traditional metaphysical questions such as, what is the ultimate ground of reality, or what exists beyond existence? These questions are not rejected, but deliberately bracketed. The text is concerned with what must already be true for such questions to arise, and with what survives when their hidden assumptions are removed. The method employed is diagnostic rather than constructive. Apparent problems, circularity, infinity, self-reference, lack of foundation, are not resolved by adding new entities or principles, but by examining whether they actually constitute failures of coherence. In many cases, what appears problematic dissolves once the demand for a privileged terminus is abandoned. This places the work in proximity to structural, anti-foundational, and analytic traditions, but it does not belong cleanly to any single school. It avoids speculative metaphysics, resists linguistic mysticism, and makes no claim to finality. Its commitments are minimal, that dependencies must resolve, that self-reference must converge, and that explanation succeeds when constraints are preserved. The reader is invited to engage with the text not as a doctrine, but as a test. If the framework holds, it should do so without appeal to hidden grounds. If it fails, it should fail visibly, through unresolved references or broken constraints. No agreement is required, only careful attention to how explanation is being used. This work is written for readers interested in the limits of grounding, the structure of explanation, and the conditions under which coherence survives. It is not a guide to belief, but an exercise in seeing what remains once belief is no longer allowed to do explanatory work. Less than nothing, on coherence, dependency, and grounding without foundations. Is a state less than nothing possible? If absolute nothing cannot exist as a state, a natural follow-up question arises. Can there be something less than nothing? At first glance, the question appears paradoxical. Nothing is usually treated as an endpoint, a final boundary beyond which no further comparison is possible. Asking whether there can be less than nothing seems to presuppose a scale that nothing itself was meant to terminate. For this reason, the question is often dismissed as meaningless or purely linguistic. This essay takes a different approach. The question is not asked in order to posit a new ontological state, nor to suggest the existence of a deeper void beyond existence. It is asked because it exposes a structural tension in how grounding, dependence, and ordering are usually understood. If nothing cannot exist as a state, yet continues to function as a reference point in our reasoning, then the problem is not one of ontology, but of structure. Rather than asking whether less than nothing exists, the more precise task is to examine what must already be true for such a question to arise at all. What does it mean to compare, to depend, to ground, or to terminate explanation when the endpoint itself is not a thing? What replaces foundations if nothing cannot serve as one? And what kinds of structures remain coherent once appeals to absolute absence are removed? The argument that follows does not attempt to answer the initial question directly. Instead, it shows how the question dissolves into a deeper analysis of dependency, rerouting, closure, and self-consistency. In doing so, it develops a framework in which grounding does not require a core, infinity does not imply arbitrariness, and coherence does not depend on origins. 1. Definitions and minimal constraints. Before any further progress can be made, several terms must be fixed in a minimal and non-metaphorical way. These definitions are intentionally sparse. They exist only to prevent equivocation in later sections. Nothing. Nothing is not a state, domain, or condition. It is a non-instantiated reference limit. It does not exist, does not possess properties, and does not participate in relations. It functions only as a boundary concept invoked by negation and comparison. Nothing cannot ground, support, or terminate a structure. Existence. Existence is treated as domain relative. To say that something exists is to say that it is realized within a domain governed by certain constraints. No claim is made that existence is a global or universal predicate, nor that it must behave identically across all possible domains. Dependency. A dependency is a structural relation in which the definition, behavior, or stability of one element requires another. Dependencies may be direct or indirect. Dependency does not imply temporal priority, causation, or fundamentality. It only implies constraint satisfaction. Constraint preservation. Constraint preservation refers to the requirement that dependent structures remain compatible with the constraints of what they depend on. Variation is permitted, contradiction is not. Constraint preservation is the primary limiter of coherence, not material finiteness or origin. Core versus closure. A core is a foundational element assumed to ground all others. Closure, by contrast, refers to the condition in which all dependencies within a structure are satisfied without requiring an external ground. This essay argues that closure is sufficient for coherence, whereas a core is optional. These definitions establish the minimal framework required to examine whether grounding can occur without foundations, whether dependency can persist through rerouting, and why questions about less than nothing arise when limits are treated as values rather than boundaries. 2. Why less than nothing is not an opposite. The intuition that motivates the question, can there be less than nothing, usually takes the form of an implicit binary. If there is something, and if nothing is treated as the lower bound of that something, then it appears natural to ask whether there is a state that lies below that bound. In ordinary reasoning, less than suggests opposition, negation, or reversal. More implies less. Positive implies negative. Presence implies absence. This intuition is misleading. Opposites require symmetry. They require a shared scale, a common domain, and an operation that inverts values while preserving structure. Positive and negative numbers are opposites only because they are defined within an ordered system that already contains zero as a value. The same is true of gain and loss, surplus and deficit, charge and anticharge. In every such case, the opposition is defined within a domain whose structure is already given. Nothing does not belong to such a domain. Nothing, as defined here, is not a value, not a state, and not an element. It is a reference limit invoked by negation. Because it is not instantiated, it cannot occupy a position on a scale. As a result, it cannot have neighbors, opposites, or directions relative to it. The moment less and more are applied, an ordering structure has already been introduced, and with it, something rather than nothing. This is why less than nothing cannot name a state. It does not point to a deeper absence. It points to the breakdown of the ordering that made the comparison seem meaningful in the first place. The error lies not in asking the question, but in assuming that the comparison must succeed. When nothing is treated as a midpoint or boundary value, it is implicitly reintroduced as a coordinate within a domain. This smuggles structure back in under the guise of negation. Once a scale exists, both sides of the boundary are already something. The structure has created itself through the act of comparison alone, without requiring the boundary to exist as a thing. For this reason, less than nothing does not identify a hidden region of reality. It reveals that the language of opposition is being applied beyond its domain of validity. What survives this failure is not a new state, but a structural insight. Limits can organize relations without being elements of the systems they constrain. Zero in mathematics, absolute zero in thermodynamics, infinity in calculus, and horizons in physics all function this way. They are indispensable references that never appear as realized states. Nothing plays the same role. It does not divide reality into positive and negative regions. It marks the point at which comparison, negation, and ordering cease to apply. Asking what lies beyond that point does not extend the scale, it exposes its boundary. The significance of the question, then, is not that it suggests a state less than nothing, but that it forces a reconsideration of grounding. If nothing cannot serve as a foundation, and if oppositions collapse at its boundary, then any coherent structure must be supported by relations that do not terminate in absolute absence. This prepares the ground for the next step, examining how structures can remain coherent when dependencies are redirected, satisfied internally, or closed without appeal to a core. 3. Rerouting. If grounding does not terminate in nothing, and if less than nothing fails as a meaningful state, then the question of how structures remain coherent must be reframed. The traditional model assumes that dependencies point downward toward a foundation. Each element relies on something more basic, and explanation ends when a core is reached. Once the idea of a core is removed, this picture collapses. Rerouting offers an alternative. Rerouting is the redirection of a dependency without altering the realized structure. It is not duplication, replacement, or creation of new content. It is a reassignment of reference under preserved constraints. Consider a simple case. Let a structure Z depend on a value X, where X equals 15. If another value F is introduced, also equal to 15, and Z's dependency is redirected from X to F, nothing about Z changes. Its behavior, definition, and constraints remain intact. What has changed is not what Z is, but what satisfies its dependency. This redirection does not require X to be destroyed, negated, or replaced, nor does it require Z to become independent. Z remains dependent, only the path of dependence has shifted. The structure persists because the constraint it requires continues to be satisfied. This distinction matters. Rerouting does not generate new states of being. It reorganizes existing ones. It allows dependency to be maintained without privileging a unique source. In traditional foundational models, identity is often tied to origin. An element is what it is because of where it ultimately comes from. Rerouting breaks this assumption. It shows that identity can be preserved under changes of grounding so long as the relevant constraints are upheld. This is not an abstract trick. Rerouting already occurs in many domains. In mathematics, a definition can be rewritten in terms of an equivalent axiom set without changing the theorems that follow. In computation, a function can call a different implementation that satisfies the same interface. In physics, effective descriptions can replace microscopic ones without altering macroscopic behavior. In each case, dependencies shift while structure remains. Rerouting also clarifies why a core is not required. If dependencies can be satisfied by multiple equivalent structures, then no single element needs to be ontologically privileged. What matters is not where a dependency terminates, but whether it terminates coherently. Once rerouting is allowed, grounding stops being a vertical relation and becomes a structural one. Dependencies no longer need to point downward toward a foundation. They can point sideways, inward, or circulate within a network. This prepares the possibility that coherence can arise not from origin, but from closure. A structure may be stable not because it rests on a core, but because every dependency it contains is satisfied somewhere within the structure itself. The implications of this move are significant. If rerouting is permitted, then dependence does not enforce hierarchy. It enforces compatibility, and compatibility can be achieved without appeal to a foundational base. The next step is to examine what happens when rerouting is taken to its limit, when dependencies no longer point outward at all but form loops that sustain themselves. 4. Loops without a core. Once rerouting is allowed, the assumption that every dependency must ultimately terminate in a foundational element becomes optional. Dependencies no longer need to point outward toward an origin. They can point inward, sideways, or back onto each other. This opens the possibility of dependency loops, structures in which elements mutually support one another without appeal to an external ground. At first glance, such loops appear problematic. Circular dependence is often treated as a flaw, a sign of incomplete explanation, or hidden contradiction. This reaction is understandable, but it relies on a narrow conception of dependence, one that equates grounding with linear hierarchy. Not all loops are paradoxical. A dependency loop becomes incoherent only when a required condition is never satisfied. By contrast, a loop in which each dependency is fulfilled somewhere within the loop itself can be perfectly stable. What matters is not the absence of a beginning, but the presence of closure. Consider a simple loop. A depends on B depends on C depends on A. If each dependency is well-defined and mutually satisfied, the structure does not collapse. There is no missing reference and no appeal to absence. The loop does not float on nothing. It is internally constrained. This is not an exotic construction. Mutual definitions already exist in mathematics, recursive functions already exist in computation, and feedback systems already exist in physics and biology. In each case, stability does not arise from an external anchor, but from consistency across relations. The mistake is to assume that grounding must always precede structure. In loop-based systems, grounding is distributed. No single element carries the burden of explanation. Instead, explanation emerges from the network as a whole. This distinction allows a sharp separation between two kinds of circularity. The first is self-supporting circularity, in which dependencies are satisfied through mutual constraint. The second is self-negating circularity, in which a definition or condition undermines its own possibility of satisfaction. Only the latter leads to paradox. A loop fails when it contains an undefined reference, an unmet condition, or a dependency that ultimately points to nothing. A loop succeeds when every dependency resolves within the system, even if no element is privileged as fundamental. This is why the absence of a core does not imply the absence of grounding. Grounding can be achieved through closure rather than origin. A system can be self-sustaining without being self-caused in any temporal or metaphysical sense. Seen from this perspective, the demand for a core begins to look less like a necessity and more like a habit of thought. It reflects an expectation that explanation must end at a singular point rather than at a stable configuration. Loops without a core are not violations of coherence. They are alternative forms of it. The next question is whether such structures can be extended indefinitely. If dependencies can loop, and if rerouting can redirect grounding internally, what prevents the system from expanding into infinite chains or infinite networks without constraint? That question leads directly to the issue of infinity. 5. Infinite structures without foundations. If dependencies can be rerouted and satisfied through closure rather than origin, and if coherent loops can exist without a core, then a further question follows naturally. What prevents such structures from becoming infinite? If no foundation is required, why should dependence ever stop? The short answer is that nothing, in principle, prevents infinity. The longer answer is that infinity does not imply arbitrariness. It is important to distinguish between infinite depth and unbounded freedom. An infinite dependency structure does not automatically permit infinite variation. Dependence is transitive, but constraint is not diluted by repetition. Each additional layer, redirection, or loop must still preserve the constraints that define the structure as coherent. An infinite chain of dependencies is therefore not a collapse into chaos. It is an extension under restriction. This distinction already appears in familiar contexts. Infinite mathematical sequences can converge to finite values. Infinite series can be bounded. Recursive definitions can produce stable behavior. In none of these cases does infinity undermine coherence. What matters is not the number of steps, but whether each step respects the same underlying conditions. The same applies here. An infinite structure of dependencies may exist without a foundation, provided that every dependency is satisfied somewhere within the structure and that no unresolved reference is introduced. Infinity increases complexity, not permissiveness. This also clarifies why appeals to material finiteness, finite particles, finite time, or finite state spaces are not the fundamental constraint. Even if matter and time were infinite, coherence would still be limited by compatibility. Conversely, even a finite system can be incoherent if its dependencies fail to resolve. The real constraint is not size, duration, or quantity, but invariance. Across rerouting, looping, and extension, certain conditions must remain unchanged. These invariants may be minimal, but they are non-negotiable. Without them, the structure loses definition. Infinity, therefore, does not eliminate grounding, it changes its form. Grounding becomes distributed rather than localized, sustained by the persistence of constraints rather than by the presence of a base. This removes the need for a final layer, an ultimate universe, or a privileged core. It also avoids the opposite extreme, the idea that without foundations, anything is possible. Infinite structures are not free form. They are disciplined by what they must continue to satisfy. The question is no longer whether there is a bottom, but whether there is stability. This leads to a final refinement. If infinite structures can exist without foundations and if loops can sustain themselves, then what guarantees stability at all? What prevents a coherent system from drifting under rerouting and extension until it no longer satisfies its own conditions? To answer that, a new concept is required, one that replaces the idea of a core without reintroducing it. That concept is the fixed point. 6. Fixed points. If a structure can be coherent without a foundation, and if infinite dependency networks can exist under preserved constraints, then the remaining question is what guarantees stability. Without a core, what prevents rerouting, looping, and extension from drifting until the structure no longer satisfies its own conditions? The answer is not origin, but invariance. A fixed point is a configuration that remains unchanged under the operations permitted within a system. It is not a foundational element and does not ground the structure by existing beneath it. Instead, it grounds the structure by being preserved through it. When dependencies are rerouted, loops are formed, or extensions are added, a fixed point is what remains invariant across those transformations. This does not require formal mathematics to grasp. A definition rewritten in equivalent terms reaches a fixed point when further rewriting no longer changes its meaning. A computational process reaches a fixed point when repeated application produces the same result. A physical system reaches a fixed point when macroscopic behavior stabilizes despite ongoing microscopic change. In each case, stability does not come from a privileged starting point. It comes from convergence. Within the framework developed here, a fixed point replaces the role traditionally assigned to a core. It does not answer the question, what is most fundamental, but the question, what must remain satisfied? This shift is decisive. It allows coherence without hierarchy and grounding without origin. Importantly, a fixed point does not have to be unique, final, or singular. Multiple fixed points may exist within a structure and a system may move between them. What matters is that at any moment of stability, dependencies are satisfied and constraints preserved. This also clarifies why loops can be coherent. A loop is stable when traversal of the loop leaves the structure unchanged. If passing through the loop alters the conditions it depends on, instability results. If it does not, the loop functions as a fixed point. Seen this way, rerouting does not threaten coherence. Rerouting tests whether a structure converges back to the same conditions. If it does, stability is maintained. If it does not, the structure dissolves, not because it lacked a foundation, but because it lacked a fixed point. Fixed points, therefore, do not reintroduce a hidden core. They are not things, places, or layers. They are conditions of persistence. They mark where variation ends and coherence begins. This reframes grounding entirely. Grounding is no longer something a structure rests on. It is something a structure returns to. With this distinction in place, the remaining challenge is to separate stable self-reference from paradoxical self-reference. Not all systems that refer to themselves converge. Some collapse. Understanding the difference requires examining self-reference directly. That task belongs to the next section. 7. Self-reference and paradox. Self-reference is often treated as inherently dangerous. Circular definitions, self-dependent statements, and feedback loops are commonly associated with contradiction, collapse, or paradox. This suspicion is understandable, but it is also imprecise. Not all self-reference fails, and not all failure takes the same form. The mistake is to treat self-reference as a single phenomenon rather than a family of structurally distinct cases. A self-referential structure becomes paradoxical only when it undermines the conditions required for its own evaluation. When a system refers to itself in a way that prevents any stable interpretation or resolution, coherence fails. When self-reference preserves the conditions it depends on, coherence remains intact. This distinction can be made precise. A self-supporting structure is one in which self-reference converges. Traversing the reference returns the system to the same conditions under which it began. Such a structure functions as a fixed point. Definitions remain valid, dependencies remain satisfied, and no unresolved reference is introduced. A self-negating structure is one in which self-reference destroys the possibility of satisfaction. The classic liar pattern illustrates this clearly. A statement that asserts its own falsehood removes any stable truth value. The problem is not self-reference itself, but the incompatibility of the conditions the reference imposes. A third category is often overlooked: self-undefined structures. In these cases, self-reference does not negate itself, but neither does it converge. Evaluation never terminates because no conditions are ever satisfied. The structure does not contradict itself, it simply fails to resolve. These three cases, self-supporting, self-negating, and self-undefined, exhaust the possibilities. Only the first is coherent. The relevance of this distinction to grounding is direct. Loops and rerouting do not threaten coherence so long as self-reference converges to a fixed point. A system collapses not because it lacks a foundation, but because it lacks convergence. This also explains why appeals to absolute nothing are destabilizing. Nothing cannot participate in convergence. It cannot satisfy a dependency, anchor a reference, or function as a fixed point. Any structure that implicitly relies on nothing as a terminus becomes self-undefined. By contrast, structures that close on themselves through satisfied constraints avoid paradox without appeal to origin. Their self-reference is stabilizing rather than destructive. The lesson is not that self-reference should be avoided, but that it must be constrained. Coherence is preserved when self-reference returns a system to itself unchanged. Paradox arises when self-reference prevents such return. With this distinction in place, it becomes possible to evaluate dependency structures directly. Rather than asking whether they are circular, the correct question is whether they converge. The final task, then, is practical rather than speculative. How can such convergence be tested? What criteria distinguish a coherent dependency network from one that only appears stable? That task belongs to the next section. 8. A structural test for coherence. At this point, the question is no longer whether non-foundational structures are possible, but how to distinguish coherent ones from unstable or ill-defined ones. If grounding can occur through closure rather than origin, then coherence must be evaluated structurally, not hierarchically. What follows is not a formal proof system, but a minimal test suite. Each condition addresses a specific failure mode identified in earlier sections. A structure need not be simple to be coherent, but it must satisfy all of them. Resolution of dependencies. Every dependency within the structure must resolve to a satisfiable condition. Resolution does not require termination in a foundational element, but it does require that no dependency points to an undefined reference. If any dependency ultimately relies on an absence, a void, or an uninstantiated placeholder, the structure is incomplete. Closure without appeal to nothing. A structure must be closed under its own rules. Closure means that all required conditions are met internally, either directly or through loops. Any appeal to absolute nothing as a terminus signals failure. Nothing cannot satisfy a dependency and cannot function as a boundary within the structure itself. Constraint preservation under rerouting. If dependencies are rerouted, the structure must preserve its defining constraints. Rerouting may change how dependencies are satisfied, but not what they require. If rerouting alters the behavior or definition of elements in a way that violates prior conditions, the structure lacks invariance. Convergence of self-reference. Self-referential paths must converge to a fixed point. Traversing a loop should return the structure to the same conditions under which it began. If self-reference produces contradiction or endless deferral without resolution, the structure is either self-negating or self-undefined. Stability under extension. A coherent structure should tolerate extension without collapse. Adding new layers, representations, or indirect dependencies should not invalidate existing relations, provided constraints are respected. Instability under extension indicates that coherence depended on an implicit core or hidden assumption. No hidden privilege. No element should be implicitly treated as foundational unless explicitly defined as such. Privileged nodes often appear disguised as constants, givens, or just how things are. If removing or rerouting such an element destabilizes the structure, then a core has been smuggled in. These criteria do not guarantee truth, completeness, or correspondence with reality. They guarantee only coherence. That is sufficient for the present purpose. Applying this test suite reveals why many intuitive answers to foundational questions fail. Structures that appear stable often rely on undefined anchors. Others collapse under rerouting or self-reference. A small number survive, not because they reach a bottom, but because they close on themselves without contradiction. This reframes the original question. Asking whether there can be a state less than nothing becomes less important than asking whether a structure implicitly relies on nothing to function. In every case where coherence fails, the failure can be traced to an unresolved reference rather than to infinity, circularity, or lack of origin. With a method for testing coherence in place, the final step is to assess the broader implications. What follows from accepting that grounding does not require a core, that infinity does not imply arbitrariness, and that coherence is a matter of closure rather than foundation. That assessment concludes the essay. 9. Consequences. Accepting that coherence does not require a core has several immediate consequences. None of them require speculative metaphysics, and none of them depend on answering questions that are in principle undecidable. They follow directly from the structural framework developed in the preceding sections. First, the original motivating question can now be addressed without ambiguity. A state less than nothing does not exist. The failure of that idea is not due to lack of imagination or linguistic limitation, but because less than presupposes an ordering that collapses at the boundary where nothing is invoked. The question remains valuable not because it points to a hidden region of reality, but because it exposes the limits of foundational thinking. Nothing cannot function as a ground, and attempts to place something beyond it reveal where ordering itself fails. Second, the absence of a core does not imply that anything is permitted. Removing foundations does not remove constraints. On the contrary, it makes constraints more visible. When explanation no longer terminates in a privileged element, coherence must be maintained everywhere. Dependency, rerouting, and extension are allowed only so long as invariants are preserved. The system is not held together by an origin, but by consistency. Third, infinite structures cease to be threatening. Infinity does not produce paradox by itself. What produces paradox is unresolved reference. An infinite dependency network can remain coherent indefinitely if every dependency is satisfied somewhere within the structure and if self-reference converges. Conversely, even a finite structure can fail if it implicitly relies on an undefined anchor. The relevant distinction is not finite versus infinite, but closed versus open-ended in the sense of unresolved conditions. Fourth, the idea of an ultimate or true universe loses its necessity. If grounding can be achieved through closure and fixed points, there is no requirement that reality terminate in a final layer, a first cause, or a privileged domain. This does not deny the possibility of such a layer. It shows that coherence does not depend on it. The demand for a core becomes optional rather than compulsory. Fifth, this framework clarifies what remains undecidable. Questions about whether there is a final layer, whether the structure is infinite, or whether alternative realizations exist cannot be settled from within the system. This is not a defect. It is a consequence of closure without origin. Undecidability here reflects structural limits, not missing information. Finally, the framework reframes how explanation itself is understood. Explanation no longer proceeds by digging downward until something inexplicable is reached. It proceeds by identifying whether dependencies are satisfied, whether self-reference converges, and whether invariants are preserved under transformation. Where these conditions hold, explanation succeeds. Where they fail, no appeal to deeper foundations can repair the break. The initial question, whether there can be less than nothing, thus resolves indirectly. The question does not point toward a deeper absence, but toward a deeper structure. It survives not as a claim about what exists, but as a diagnostic for how grounding is misconceived. The remaining task is not to add another layer, but to press what has been established into its most economical form. That task belongs to the final section. 10. Final compression. The question that initiated this essay, whether a state less than nothing is possible, cannot be answered by introducing a new ontological category. Nothing is not a state and therefore cannot admit comparison, opposition, or extension. Asking what lies beyond it does not reveal a deeper absence. It reveals the point at which ordering, grounding, and negation cease to apply. What replaces foundations is not nothing, but structure. Once dependency is understood as constraint satisfaction rather than descent toward an origin, grounding no longer requires a core. Dependencies may be rerouted without altering realized structure. Loops may close without contradiction. Infinite extensions may exist without arbitrariness. Stability arises not from where a structure begins, but from whether it converges. Fixed points replace foundations. They do not ground by being beneath everything else, but by remaining invariant under transformation. Self-reference is not a flaw when it converges. It becomes paradox only when it undermines its own conditions of evaluation. Coherence is preserved not by terminating explanation, but by closing it. Nothing plays no positive role in this framework. It cannot anchor, support, or explain. Its only function is diagnostic. Wherever an argument relies on nothing to resolve a dependency, coherence fails. Wherever nothing is avoided and constraints are preserved, coherence survives, even without origin, finitude, or hierarchy. The idea of a final layer, a true universe, or an ultimate foundation is therefore optional. It may exist, but it is not required. What is required is closure, that every dependency be satisfied, every reference resolved, and every transformation preserve invariance. The question of less than nothing thus dissolves. It does not point to a hidden state of reality, but to a mistaken expectation about how explanation must end. What remains is not emptiness, but a network of relations that holds together because it cannot fall apart without contradiction. Nothing is not the ground. Coherence is. If you like this video and find this content useful, please like the video or subscribe for future essays.